Well, hello everybody. Welcome back to algebra. We are in the quadratics chapter. I did skip 13.3. That is called completing the square. You will learn how to do that in Algebra 2. So we're going to forego that for right now. Now, remember what we're doing. We're solving for the zeros. We're finding the solutions, finding the roots of quadratic equations. So today we're going to work on what we call the quadratic formula. And your book goes into detail about how it was formed and all that good stuff, but I just want you to be able to apply the numbers and use it to solve, okay? So what you will want to do to use the quadratic formula is first put your equation in standard form. Remember, that's ax squared plus bx plus c equals 0. Okay, remember that a, b, and c can be plus or minus, positive, negative. You want to make sure it's equal to 0. You want your leading coefficient to be plus, so you may have to move it to one side or the other, okay, and always set it equal to 0. And what you will be doing once you get that is if you tried trial and error to factor and it just didn't work or it took you too long, then what you can always do is use the quadratic formula. You can plug those a, b, and c into this and get your two solutions, your two roots, okay? And the quadratic formula is x is equal to the opposite of b, negative b, plus or minus the square root of b squared minus 4 times a times c over 2a. Now it's really nice to go into Algebra 2 having this memorized, so I would say it 100 times. You'd have it memorized then. But negative b plus or minus square root b squared minus 4ac over 2a. All right, so again, we're going to need to take an equation. I wrote one up here, and we want to set it equal to 0, get this in standard form. That's what you were supposed to do in 13.1. So in this equation right here, we want to add the 3 to set this equal to 0, correct? So I'll have 5x squared minus 8x plus 3 equals 0. Remember, when this gets added on, it's going to be plus 3 on the left side. So I now have this in standard form. So the a in this case is what's in front of the x squared. So it's 5. The b is the thing in front of the x term. In this case, it's negative 8. And the c is 3. All right? So I have my a, b, and c. Now I'm going to need some room. So I'm going to go ahead and erase this. And I'm going to now plug these values into my quadratic equation. Okay, my quadratic formula. All right, so x is equal to the opposite of b. So not negative 8, positive 8. I want the opposite of what b is. Okay, plus or minus the square root of b squared. So negative 8 getting squared is 64. Minus 4 times a times c. So a is 5, c is 3. And that's all over 2 times a. All right, so let's think about this. We've got a negative 4 times 5, so 20 times 3 would be 60. Okay, so I have 8 plus or minus radical 4 over 10. I hope you're seeing all of that. Now, the square root of 4 is 2, isn't it? Okay, so 8 plus 2 would be 10 over 10. So one solution is 1. The other solution, 8 minus 2, would be 6 over 10, which I would reduce to 3/5. And these are my two solutions. Now, knowing that's the case, I have rational numbers. I could have done trial and error with that equation. It would have worked out. In fact, I'll go ahead and show it to you. I just want to kind of prove it. Okay, so I know the only way to get 5x squared is 5x and x, and 3 be 3 and 1, so plus and plus, and if I did FOIL, I would end up getting, no, I need to have minus signs, don't I? So by trial and error, I would have gotten this. So my two possibilities, right here would be 1, and here would be 3/5. If I set this equal to 0, I'd add 3, divide by 5, and get my two solutions. So this one worked with trial and error, but we used the quadratic formula. Point being, you can use the quadratic formula with every single problem. It'll always work. It just takes a lot longer. So if you can spot check it and see whether you can factor it, do so. But if it won't factor, you're going to get an irrational solution, and you need to use the quadratic formula. So let's go ahead and let's try this A. I want you to just try this A, and then I'll do another example for you. I want you to have a look at it. So do try this A. And do use the quadratic formula, please. So hopefully you set it equal to 0. You got 2x squared plus 7x minus 4 is 0. So your A is 2, your B is 7, and your C is -4. All right, so plugging into the formula, the opposite of B plus or minus square root of B squared, so 49, minus 4 times A times C. So this is a -4 times 2, -8 times -4 would be plus 32, okay? So 49 plus 32 is 81, okay? And then 2 times 2, of course, down here is 4. Now the square root of 81 is 9. So I did -7 plus 9, so that's 2 over 4. 2/4 is 1/2. -7 minus 9, ignore that. -7 minus 9, -16 over 4 is -4. So these are our two solutions. All right, let me give you one that isn't going to simplify here. So let's work out example 2. Okay, so we're going to set this example, 3x squared equals 7 minus 2x. I've got to get this into standard form. So I'm going to add 2x, I'm going to subtract 7. So 3x squared plus 2x minus 7 equals 0. I hope you're seeing that. All right, so A is equal to 3, B is equal to 2, and C is equal to -7. All right, so I'm not going to try trial and error. I'm going to go straight to the quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, and that's that's over 2 times a. All right, so negative 2 plus or minus square root of 4. Now I've got 2 negatives, so it will be plus. All right, 7 times 3 is 21 times 4, 84. Okay, so plus 84. And then that's over 6. Okay, now 4 plus 84 is 88, isn't it? Okay. Now, 88. Does that have any perfect square factors that I could simplify? Oh, yes, it does. 4. You're right. So let me simplify that. Let me erase 88, and I'm going to write 4 by 22. Okay. So what comes out? A 2. Good. So we have negative 2 plus or minus 2 radical 22 over 6. Now think about this a minute, everybody. This is like saying negative 2/6 plus 2 radical 22 over 6, isn't it? Now can't I reduce each of these? Now I can't reduce 6 into the radical, but I can reduce 2/6, right? Those are both integers. So I really can make this negative 1/3 plus radical 22 over 3. The 2/6 is getting reduced. So negative 1 plus radical 22 over 3. Now I'm perfectly happy with you leaving this like this. The book does plug this into the calculator, and apparently that would be, I don't have that memorized, so let me see what that is. 22, the square root, and we would, hold on here. So 4.7, we'll just round it. So you could say negative 1 plus 4.7, so negative 3.7 over 3, and apparently that is negative 1.9. And then negative 1 minus 4.7 over 3, so you have 1.2 and then negative 1.9. So that's fine. But I totally would be happy with you just leaving it in irrational form, all right? So let's just do, let's do another one. Let's do C and D, okay? And remember, they can ask you to solve using the quadratic formula. They can say use the quadratic formula to find roots, all right? They could say find the zeros, okay? So, like I said, let's do C and D. You do not have to get approximations. Let's just leave them in irrational form, okay? So C and D. Make sure I have the right problem. All right. All right, so for A, I set that equal to 0, so I subtracted 5. My A is 2, B is negative 4, C is negative 5. Plugging into the formula, the opposite of B plus or minus square root of B squared minus 4 times A times C. All right, so this becomes 16 plus 40. Negative times negative is positive. 8 times 5, 40. Okay, and then 2 by 2 is 4. So 4 plus or minus radical 56. Okay, 56 is going to be equal to 4 times 14. So the square root of 4 comes out as 2. Now 4 over 4 reduced to 1. Plus or minus 2/4 would be 1/2 radical 14. Now again, you could get a decimal approximation for that, add it to 1, divide by 2, or subtract it, okay? But this is fine to leave it like this. All right, for D, I set that equal to 0. A is 1, B is 5, C is 3. The opposite of B, plus or minus B squared minus 4 times A times C over 2 times A. So negative 5 plus or minus 25 minus 12 over 2. 25 minus 12 is 13, and this is done. There's nothing to simplify there. Good to go. All right, so there is more to this chapter, but we're going to skip the discriminant. It's a way to determine whether you have real solutions or irrational ones. But you'll learn more about that in Algebra 2. I just want you to be able to apply the quadratic function to basic equations. So go to RenWeb, see what your assignment is. Have a wonderful afternoon.